What if the Moon, Earth's steadfast companion, were to suddenly disappear without a trace? The consequences would be far more catastrophic and wide-ranging than merely losing a romantic glow overhead. Our very planet, life as we know it, and even our concept of time would be thrown into disarray, a cascade of events unfolding across moments, days, years, and millennia. The immediate aftermath would be nothing short of disorienting, perhaps even terrifying. The night sky, a familiar canvas adorned with the moon's gentle light, would plunge into an unprecedented darkness. Stars that were once hidden by lunar glow would blaze forth with startling clarity, painting a celestial tapestry unlike anything humanity has ever collectively witnessed. While this might sound beautiful to stargazers, the loss of moonlight would profoundly impact nocturnal ecosystems. Many predators rely on the dim illumination to hunt, and their prey would suddenly find themselves navigating an utterly black landscape, leading to a drastic shift in the delicate balance of these environments. Some species could face extinction as they struggle to adapt to the profound alteration of their nightly world. Beyond the sudden darkness, the most immediate and tangible physical effect would be on our oceans. The Moon is the primary driver of Earth's tides, its gravitational pull creating the rhythmic ebb and flow that defines our coastlines. Without it, the colossal gravitational force that shapes our planet's watery margins would instantly cease. Tidal bulges, those immense swells of water pulled across the globe by lunar gravity, would collapse. This wouldn't mean a complete absence of tides, however. The Sun, despite its greater distance, still exerts a gravitational influence. We would be left with only solar tides, which are significantly smaller, estimated to be about 1/3 the size of our current tides. This dramatic reduction in tidal range would lead to a period of intense upheaval along coastlines. Waters would likely recede from their usual high marks, exposing vast swaths of seabed that were once regularly submerged. For intertidal ecosystems, those vibrant zones between high and low tide, this would be a death sentence. Crabs, mussels, starfish, and a myriad of other organisms that have evolved to depend on these regular fluctuations for survival would perish. The knock-on effects for marine and land animals that rely on these coastal zones for food would be catastrophic, potentially leading to mass extinctions across the globe. The disappearance of the Moon would also have an impact on the Earth's very rotation, albeit one that would manifest more subtly over time. For billions of years, the Moon has been a silent brake on our planet's spin. The tidal friction generated by the Moon's pull on our oceans has gradually, imperceptibly, slowed Earth's rotation, lengthening our days. Billions of years ago, an Earth day might have lasted a mere 6 to 12 hours. Today, it's a familiar 24. Without the Moon's constant tug, this deceleration would effectively halt. While the change wouldn't be instantaneous, our days wouldn't suddenly shorten back to prehistoric lengths, the gradual lengthening of the day would cease. Over geological timescales, this could mean that future days wouldn't continue to grow longer, freezing our daily cycle at its current pace, or even subtly altering it as other minor forces become more dominant. However, the most profound and unsettling long-term consequence of a vanished moon would be the destabilization of Earth's axial tilt, 5 degrees relative to its orbit around the Sun. This tilt is what gives us our seasons, creating predictable patterns of warmth and cold across the globe. The Moon acts as a gigantic gyroscope, its gravitational pull stabilizing Earth's axial tilt. Without this lunar influence, Earth's tilt would no longer be held in check. Instead, it would begin to wobble erratically, much like a spinning top that's losing momentum. Over tens of thousands or even hundreds of thousands of years, this wobble could become extreme. Earth's axial tilt could vary wildly, shifting from virtually no tilt at all to an inclination of 45 degrees or even more. Imagine a world with no tilt. The poles would receive little to no direct sunlight, plunging vast regions into perpetual, deep freeze, while equatorial regions would experience constant, intense heat with no seasonal variation. Conversely, a planet tilted dramatically could mean that the poles would point directly towards the sun for extended periods, leading to scorching summers followed by equally brutal winters of perpetual darkness. Such extreme climatic shifts would render large portions of the planet uninhabitable, causing widespread extinctions and fundamentally reshaping the course of life on Earth. Predictable seasons, which underpin agriculture and entire ecosystems, would vanish, replaced by chaotic and unpredictable weather patterns. This immense change would dwarf even the immediate tidal chaos. Ocean currents, those vast global conveyors of heat and nutrients, are also significantly influenced by tidal movements. With substantially reduced tides, these currents would weaken or alter their paths, disrupting the global distribution of warm and cold water. This would have a profound impact on global climate, potentially leading to more extreme and less moderated temperatures across the continents. Regions currently warmed by oceanic currents, like parts of northern Europe, could experience far colder climates, while others might become drastically hotter. The delicate balance of Earth's climate system, honed over eons, would be severely compromised. The biological rhythms of countless species are intrinsically linked to the lunar cycle. Beyond nocturnal hunting, many marine animals time their reproduction and migration patterns with the phases of the moon. Coral polyps, for instance, coordinate their mass spawning events with specific lunar phases. The Barrow's petrel, a seabird, times its migratory routines to the moon. The sudden absence of this celestial cue would throw these intricate biological clocks into disarray, leading to reproductive failures, disruptive migrations, and potentially further extinctions. Terrestrial animals would also be affected, as their nightly activities and even their perception of time are often subtly influenced by lunar light cycles. Even human society, despite its technological prowess, would feel a profound impact. Our calendars, steeped in lunar origins, would lose their celestial anchor. While we now rely on atomic clocks for precision, the cultural and psychological significance of the moon is immeasurable. It has inspired countless myths, religions, stories, poems, and artistic expressions across all civilizations. Its disappearance would leave a deep void in our collective consciousness, a symbolic loss of immense magnitude. Navigational methods, particularly for those at sea before the advent of GPS, historically relied on lunar positioning. While less critical today, the absence of such a prominent celestial marker would be felt. Moreover, the moon has served as humanity's first stepping stone into space. It's a natural laboratory, a relatively close body where we can test technologies, gather resources like frozen water, and learn about the early solar system without venturing too far from home. Without this vital outpost, our ambitions for deep space exploration would undoubtedly be altered, potentially becoming more challenging and expensive as we lose a crucial resource depot and testing ground. Thinking about the Earth without its moon is to contemplate a fundamentally different planet. It's not just a change in scenery, It's a complete recalibration of fundamental planetary processes. Days would potentially be shorter, though this would be a very slow change. Tides would be greatly reduced, drastically altering coastal ecosystems and oceanic circulation. But perhaps most critically, the stabilizing influence on Earth's axial tilt would be gone, leading to erratic and extreme seasonal variations that would challenge the very survival of complex life. Our Earth, with its moderate climate and rich biodiversity, owes an immense debt to its large, close lunar companion. The Moon isn't just a pretty orb in the night sky. It is an indispensable part of our planet's identity, a vital architect of its physical and biological systems. Its sudden disappearance would be a cosmic cataclysm, reshaping our world in ways both immediate and agonizingly slow, leaving behind a planet profoundly altered and forever changed.